Hello dear students, welcome back to the NCERT science class of 10th standard. Dear students, we are studying the second topic, acid, base and salts, in which we have already studied about the acids, bases and next we have started to study the salts, in which already we have studied the 4 salts. Next, today we are going to study the 5th salt, that is baking soda. That is, its chemical formula of baking soda is NaHCO3. That is, common name of baking soda is sodium hydrogen carbonate. Sodium hydrogen carbonate. Common name of baking soda is sodium hydrogen carbonate. Next, dear students, today we are going to study, that is about the preparation of sodium hydrogen carbonate. How the sodium hydrogen carbonate is preparing. See, the sodium hydrogen carbonate or sodium bicarbonate is prepared by passing the ammonia and carbon dioxide gas through the saturated solution of sodium chloride. See here, we are having saturated solution of sodium chloride. Saturated solution of sodium chloride on passing the carbon dioxide and ammonia gas. By passing the gas like ammonia and carbon dioxide gas through a saturated solution of sodium chloride, we will get a sodium hydrogen carbonate. We will get a sodium hydrogen carbonate, and next ammonium chloride will be separated out. Isn't it? Here we have to write in examination him as how would you prepare the sodium hydrogen carbonate. Sodium hydrogen carbonate is prepared. Sodium hydrogen carbonate is prepared by passing the carbon dioxide and ammonia gas through the saturated solution of sodium chloride. We will get a sodium hydrogen carbonate. Next, dear students, uses of sodium hydrogen carbonate or sodium bicarbonate. In which field we are using the sodium hydrogen carbonate? Now we are going to learn here. Say, number of uses are there. First, dear students, sodium hydrogen carbonate is using as a baking soda or baking powder. See, dear students, in the food industry, see here what happens, dear students. Sodium bicarbonate is using a baking soda. See here what happens, dear students. Sodium hydrogen carbonate and reacting with the acid like a tartaric acid is a mild acid. The tartaric acid is a very mild acid which contains hydrogen ion concentration. See here, on reacting the sodium bicarbonate along with the tartaric acid, that will produce a gas, and next a sodium bicarbonate or a baking powder or baking soda that we will prepare here. Sodium hydrogen carbonate and reacting with the mild acid, that is a tartaric acid, it will produce a baking powder, that is along with that carbon dioxide gas will be liberated. See here, dear students, you might have saw that cake and breads are spongy in nature. Why it is spongy in nature? See, dear students, when we add the baking soda in food, that it will liberate a carbon dioxide gas. It will liberate a carbon dioxide gas. That carbon dioxide gas forms the bubble-like structures in the dough. That's why it forms a dough or the bubbles. Then it becomes a spongy when carbon dioxide gas is released out. Next, dear students, the next used as an antacid. Antacid, you have already studied the antacid, the meaning of antacids. The antacids are these are the medicines that we are taking during the acidity. Then when we are suffering from the acidity, that orally we are taking the basic substance that is called as the antacids to neutralize the acidity in our stomach. For example, milk of magnesia that you have studied, magnesium hydroxide. See here what happens, dear students. Baking soda is also used as a antacid. See here what happens, dear students. Already hydrochloric acid is present in our body. In our stomach, hydrochloric acid is secreted by the gastric glands in our stomach. That will be neutralized. See, that will be neutralized by the sodium hydrogen carbonate that releases the sodium chloride and water molecule. Next, carbon dioxide gas will be liberated. See here, sodium hydrogen carbonate is also used as an antacid, isn't it? Next, dear students, the third one most important use, that is used as a soda acid fire extinguishers. Soda acid fire extinguishers. See here what happens, dear students. On mixing the sodium hydrogen carbonate, sodium hydrogen carbonate with sulfuric acid. When we mix the sodium hydrogen carbonate with a sulfuric acid, it will liberate a carbon dioxide gas. You know the carbon dioxide gas is a fire extinguishing gas. Fire extinguishing gas. See here, in your textbook he has given one activity. Take a large size bottle in which you have to take a sodium hydrogen carbonate or sodium bicarbonate. Half of the bottle you have to take the sodium hydrogen carbonate and take one separate small test tube. Take a small test tube in which you have to take a sulfuric acid. The test tube we have to tie with a thread and we have to hang freely in that large size bottle which contain sodium hydrogen carbonate. Then that we should have to take care that sulfuric acid should not be mixed with the sodium hydrogen carbonate when we put a test tube which contains the sulfuric acid, and put the rubber cork with a side tube and mix it, tilt it, that bottle which contains sodium hydrogen carbonate. In that way we have to take, see here we have to take a large size bottle, see we have to take a large size bottle and we have to hang a test tube which contains sulfuric acid. Next we have to take a sodium hydrogen carbonate, sodium hydrogen carbonate here we have to take. Next here in that test tube we have to take H2SO4, sulfuric acid we have to take, and put it a rubber cork, with a rubber cork, tight rubber cork hanging with a thread, and next we have to put a side tube. See here what happens, dear students, when you tilt the bottle, the whole sulfuric acid will get mixed with the sodium hydrogen carbonate. Whatever the sulfuric acid is present in that small test tube, that will get mixed with the sodium hydrogen carbonate and produces the carbon dioxide gas. That carbon dioxide gas that will move through a outlet. Then further content will produce, that is sodium sulfate will produce and water molecule will produce. The carbon dioxide gas will be produced. Then we have to test which kinds of gas is produced. How can you confirm the carbon dioxide gas is produced when a sulfuric acid reacts with the sodium hydrogen carbonate? See here what happens, dear students, we have to bring a burning candle. At the outlet of the side tube. What happens here? The burning candle will be extinguished off. Why? Because that gas, whatever the gas is liberated on reacting with the sulfuric acid with the sodium hydrogen carbonate, the gas will liberate. That gas is a carbon dioxide gas. The carbon dioxide gas is a fire extinguishing gas. That's why what happens here? That will be extinguished out. The fire will be, a flame will be extinguished out. That's why here that we can produce a fire extinguishing gas. Next, dear students, the next result, that is plasters of Paris. The last one, that is plasters of Paris. The plasters of Paris is prepared on heating the gypsum. That gypsum that we are using in the cement, preparation of cement, the gypsum we have to heat to a temperature of 373 Kelvin. 373 Kelvin means at 100 degrees Celsius. When we heat the gypsum, the formula of gypsum is calcium sulfate. That is anhydrous calcium sulfate. On heating the anhydrous calcium sulfate of the gypsum at 373 Kelvin, we will get the calcium sulfate or hemihydrated calcium sulfate is nothing but the plasters of Paris. Plasters of Paris. This one is the plasters of Paris. That is, this one is the gypsum. This one is the gypsum. That is, on gypsum heating with heating the gypsum at 373 Kelvin, we will get the plasters of Paris. See again, dear students, whatever we got the plasters of Paris, again when we add the water, required amount of water, when we add the water in the plasters of Paris, we will get a hard solid that is called as the gypsum. Again, it is a reversible process. When we heat the gypsum, we will get the plasters of Paris. When we add the water molecule in the plasters of Paris, again we will get back the gypsum, isn't it? Next, uses of gypsum. See here what happens, dear students, used by the doctors, gypsums, that is plasters of Paris are used by the doctors for the supports of fractured bones. Whenever any patients are getting the fractures of bones, that time the doctors will put the plasters, that is prepared with the help of plasters of Paris. Next, dear students, used for making the toys. You might have saw the different toys that is made by the plasters of Paris. Next, decorative materials like flower pots and all, that is prepared by the plasters of Paris. Decorative material. Next, after this one, dear students, that plasters of Paris is using in the airtight bottles to tight the airtight, that we are using the plasters of Paris. Next, dear students, the important concept, that is hydrated salt. You might have saw that here calcium sulfate or gypsum with water molecule. You know the formula of calcium sulfate. Commonly we can say that calcium sulfate means CaSO4. That we can say, but here 2 molecules of water is there. That such water, such molecules, such salt molecule which contains the water molecules, the salts which contains the water molecule, such salts are called as the hydrated salt. Hydra means water, hydrate means water. The salt which contains water molecule are called as the hydrated salts. The salts which contains water molecule are called hydrated salt. See here, the salts which contains water molecule, this water, that calcium sulfate that contains water molecule, the salt which contains water molecule, that salts are called as the hydrated salt. Next is that water molecule. What we are calling for that water molecule, that is called as the water of crystallization. That whatever the water molecule which is present along with the salt molecule, that water molecule is called as the water of crystallization. And next, the salt which is present along with the water molecule, we are calling it as a hydrated salt. Next, dear students, we will study in the next class. Thank you.